So we're still working on 5.7. There are essentially about 2 things that I have left to teach you in 5.7. So I may get through with them and I may not. So here's the first one that I want to talk about. This is example 2. I kind of skipped around yesterday and taught you some stuff out of order. So you're given this polynomial. F of x is equal to x to the 5th minus 4x to the 4th plus 4x to the 3rd plus 10x squared minus 13x minus 14. And they asked me to find all zeros. Now, there is a faster way to do this problem, okay? But because I'm trying to really practice with you and everything, we're going to kind of treat it like your little test Tuesday, Wednesday, whichever day you take it, okay? So, first thing I want to do is I want you to tell me the number of solutions. How many, guys? Very good. The highest exponent is the number of solutions. People, if you missed that, we've been doing that one thing for like, I don't know how many months now. Okay? It's going to be shameful. Now I want you to list the possible rational roots. I'll give you 1 minute. Okay, so what are your possible rational roots? Yeah, don't forget that plus or minus. 1, 2, 7, and 14. Very good. All right, so now I want you to fill out Descartes' rule of sign. Okay, y'all got them? The pattern still happens, okay? So, Spencer. Okay, so first you're going to count the sign changes in f of x. So from a positive to a negative, there's 1, 2, 3, so there's 3. Or 1, because you find it and then you subtract 2 from it until you can't subtract 2 anymore. Y'all remember? Okay, then to find the negative roots, you first have to find f of negative x. All that means is that every time you have an odd exponent, it is going to change his sign. So this one changes signs. This is an even exponent, so he keeps his sign. Odd exponent changes his sign. Even exponent keeps his sign. Odd exponent changes his sign. He doesn't even have an x, so you can't change his sign. And then you count these sign changes. Negative, negative, negative. 1, 2. So there are 2 or 0. Okay? Now, you got to make all possible combinations. So 3 has to go with 2 and 0. He's already with 2, so now I pair him with 0. 1 has to go with 2 and 0. So he's already with 0, so I have to pair him with 2. And then the i's are my fillers. Every row, when you go across, has to total 5. Okay? So 3 and 2 make 5. I don't need any. 1 and 0 make 1, so I need 4. Are y'all playing with me? 3 and 0 make 3, so I need, very good. And 1 and 2 make 3, so I need 2. Okay. All right. So, while some people might look at this and say, well, that's not very helpful, okay, I'll show you some ways that it could be helpful. First of all, if I find one negative, what do I know?
That either
Yeah, that there's another one somewhere, okay? There isn't, I mean, you can't have one negative. I either got 2 or 0. Do you see what I'm saying? If I find 2 positives, what do I know? Yeah, it has to be 3. You have to have another one in there, you see? So it can be kind of helpful, all right? So now, here's where this problem would stop. For the 50-point test, it would stop. I mean, because that's just a little too much, all right? So now we're going to say how you really would probably work this problem if they said find all the zeros, which is to use a calculator. Okay? So I just wanted to practice these things with you to make sure that you could do them. All right.
you would find it with the calculator by finding the minimum.
I'm going to show you. That's exactly right. So, look, you don't have to put it in your calculator. Just look at mine because I did it. All right? So, here's the equation. I put it in there, and then I press Zoom 6. Oh, that's just like the, I did that with y'all the other day, didn't I? Oh, my word. Y'all should, next time I start to do it, say, stop. No, Miss Davis, don't touch that. Ah. Well, I was doing really good with my asthma until yesterday. I got to laughing at something too hard and had an asthma attack. Haven't quite recovered from it yet. All right, so then I went Zoom 6 and I graphed it. And this is what it looks like. Okay? Now, yesterday, did we graph something yesterday in this class? Okay, so we talked about multiplicity. Did we call it that? Okay, but we graphed something, right? So, what do I, first of all, I look at this and I go, ooh, it looks like it crosses at -1 and +2, right? So, being a good student like you guys are, I'm going to go to my little T-chart and check it out. -1, yes, and 2, yes. So I see both of those are zeros, all right? So I'm going to go back to my graph. Now, it goes through 2, but it bumps this one right here. So what does that tell you about that? It's a double root. Very good. And that's what we call multiplicity. Its multiplicity is even, where his multiplicity is odd. Okay? That when someone says something, that's what they're talking about. Okay? Now I'm going to say this. I'm looking in my book. I'm seeing if they call it multiplicity in your book. In our pre-cal book, that's what we call it. I don't think they call it anything in your book, but that's what it's called.
So the solutions would be -1 double root 2.
That's exactly right.
Because
Okay.
negative
It
one
doesn't
is
call that in your book, so you're not going to see that in your book. But I'm going to say this in the pre-cal book, and next year, that's what we call it. We talk about the multiplicity of a function of a factor determines what that graph is going to do at that 0. If it's an even multiplicity, it's going to bump it and bounce right off of it. Okay, and if it's odd, it's going to go through it. So just like you guys knew that at -1, it was a double root. And here at 2, it's just a single root. All right, so we're going to go back to this problem, and down here, I'm going to write -1, what? Double root. Very good. And then I'm going to write 2. Now, how many roots do I know? 3. Because it's -1, -1, and 2. All right, how many do I lack? 2 of them. And they are imaginary. Spencer, how do you know they're imaginary?
Because we graphed it and there were only 3 real solutions, so therefore the other 2 have to be.
That's exactly right. Okay? And can you figure out which one it is up here, which row it is?
Bottom.
Yeah, it's this one right here. It's 1 positive, 2 negatives, and 2 imaginary. Okay? I mean, that's not, you don't have to go up here and find it or anything, guys. I'm just showing you that this chart, it is truthful, okay?
You're like, yes, that's right. So you start checking it.
Oh, I'm sorry. Okay, so there we are. Now, what's the only way to find imaginary roots? What's the only way to find imaginary roots? Quadratic formula. Okay? So, it's the quadratic formula, guys. That's the only way you'll ever find. Are you going to see imaginary roots on a calculator? No. I see that, oh my word, I must have some, right? Because I know it has 5 roots, and I'm counting 1, 2, 3, so the other 2 have to be imaginary, but I'm not going to see them. Remember when we did that worksheet, and we could check the real roots on the graph, but the imaginary roots, you were like, oh, the only thing I can check is say, yep, he never crosses the x-axis. You see what I'm saying? Okay, so how am I going to get this thing right here down to a quadratic?
You're going to synthetic division of -1 and 2.
Very good. How many times do I have to do synthetic division to get a 5th degree equation down to a 2nd degree equation? 3 times.
You have to use -1 and do -1 again.
Oh, so that threw the kids off this morning a little bit, okay? They said, yeah, we're going to do synthetic division. They used -1, and then they used 2, and then they were like, oh my word, what are we going to do? And someone goes, oh, we have to use -1 again, okay? Does the order that you do them in affect it? No, it's not going to make any difference. Okay, so what do y'all want to use first? -1? Okay. Now, look, everybody look up here because I want to warn you of something, okay? This is a common mistake. Are we going to use these numbers? No. Be careful. Now, if I made that mistake and I accidentally used these, should I figure out that I made a mistake? How? You won't get 0. And you can work all day on your math facts, right? And it's not going to make a big difference. So it may take you 5 minutes to figure out that it wasn't your math facts, it was the fact that you used the wrong polynomial. Okay, so be sure and go back to the original one. So 1, 5, 4, 3, 2, 1, 0, they're all there. So 1, -4, 4, 10, -13, and -14. So I'm going to bring down the 1, multiply, and add, and multiply, and add, and multiply, and add, and multiply, and add, and multiply, and add. Okay, so there's the -1. Now what part of this big mess do I want? Yeah, these numbers right here. Okay, so what do you want to do next? -1 again? Okay, and like you just said, guys, we're using these numbers on the bottom. Do not go back up to that same polynomial up there, because that'll be, you just be like chasing your tail. Okay, so 1, oh, stop, and there I did it. Sorry. 1, -5, 9, 1, and -14. Alright, bring down the 1, multiply, add, multiply, add, multiply, and add, multiply. What are they doing? Oh. And add.
That's great.
Okay, so now I've got it down. Look, this is a 5th, so this is a 4th, this is a 3rd. Still got to do it again, okay? So what are we going to do? You got to do your 2. Don't do your negative 1 again because it won't work, okay? So we're using these numbers on the bottom. 1, negative 6, 15, negative 14. So bring down your 1, multiply, and add, and multiply, and add, multiply, and add. There's my quadratic. X squared minus 4x plus 7. Now what do we know about it right now? And you knew about it before. It's not going to, what? It's not going to factor. Why do we know that? It has imaginary roots, people. You can't get those from factoring. Okay, so that means we got to use the quadratic formula. Okay. That's my bell. That's my bell. I got a bell. That's pretty cool. You are so smart. Smart kids. I'm glad. Glad we have smart kids.
We wanted to put a 1 in 100 chance that would make the Velociraptor talk.
No, that's Ethan Reed. Did y'all know Ethan used to make that pterodactyl sound in the hall all the time? Like, oh my word. Okay. All right. So x is equal to. There was a negative boy who was kind of iffy. He went to a radical party where there was square dancing, and he missed out on 4 awesome chicks. And it was all over at 2 a.m. Okay, so let's plug our stuff in. X is equal to. The opposite of negative 4 is plus or minus the square root. Y'all always just go over here to the side. Okay, so that's going to be 4 squared is 16, minus 4 times a is 1, and 7c is 7. So that's going to be 16 minus 28. What is that? Now, is that following in my line of thinking? Yes, I was thinking I was going to get a negative under the radical, and I did. All over 2 times 1. Okay, so now I got 4 plus or minus. What is a perfect square that's a factor of 12? And I like to put the negative. You always need to put the negative because you have to pull your eye out, okay? So what's the square root of negative 4? 2i. Square root of 3 over 2. 3 terms up here. 1, 2, 3. If all those outside can be reduced by something, then you should reduce it. Does everything outside reduce by something? What? 2. So 2 goes into here 1, 2 goes into here 2, 2 goes into here 1, and there is my answer. 2 plus or minus 1i, or just I, however you like to write it, square root of 3. So there are my other 2 roots. All right, everybody okay? That's a good test question, a big test question, okay? That's a good big test question. Not a good question for the 50-point test because you will not have a calculator. That would take entirely too long, okay? All right, so I think that's a good question for your big test. Okay, now, here's what we're going to do next. This is the other skill that you don't know. We are going to write equations of polynomial functions, of polynomials, just say polynomials, given the zeros. Okay? So this is kind of like Jeopardy, right? I'm going to say, hey, these are the zeros, or this is the graph. You tell me what the function was. You tell me what the equation was. Okay, I'm trying to see when we get out of here. 30, yes, to 30, because the next one starts at the 35. Okay, so we're doing good. Look how cool. We're So, before we do this skill right here, there are a couple of things that I need to make you aware of that maybe you don't know or maybe you just haven't thought about. So, first thing is that complex and irrational roots always come in what? What kind of pairs? So that makes them called conjugate pairs, okay? And it is because of that plus or minus that makes them. So they come in conjugate pairs. Now the reason that you need to know that is because what they're going to do when they give you the zeros is they might just give you one of them and then you have to go, oh, I know there's another one. You didn't tell it to me, but I know there is another one, okay? Now, here's the thing. Last period, I had a whole bunch of kids and they didn't know what complex meant. What does complex mean? What? Yeah, that's all it means, guys. These are imaginary, okay? So, imaginary. I told them, I said, look, people, if you're in a college class and the college professor says, we're going to talk about complex numbers today, and you go, oh, that's any number over 2,000. He's not going to think well of you, all right? And it's going to be hard for him to look at you and erase that comment out of his mind, all right? He's just going to go, why are you in my class? 'Cause, yeah, where did you come from, all right? So, now listen to me. I'm going to tell you this. After this year, they're not called imaginary numbers anymore. Okay? That's why I call them complex numbers most of the time. Because anything above Algebra 2, that's what they're called, complex numbers. So I try to get you used to it. What does irrational mean? That's exactly right. It has a radical in it. So, and that's where it comes from, that plus or minus in front of that radical. These come from negatives under the radical, and these are the non-perfect squares. Okay, so they always come in conjugate pairs. So let's talk about what does that mean to us. What if I'm given some things, what do I know also? All right, so what if someone tells me that 7 plus 5i is a 0 or a root? What do you know?
Then it's 7 minus 5.
There you go. 7 minus 5i. See, you got to know that because that's what they're going to do. They're going to give you some zeros and they're not going to give them all to you. You have to know this. What if I tell you that 1 minus the square root of 3 is a root? What do you know?
1 plus the square root of 3.
1 plus the square root of 3. That's that conjugate, okay? What if I tell you that 2i is a root? Negative 2i. What if I tell you that negative square root of 5 is a root? Very good. All right, everybody okay so far? Okay, so there's another thing that I want you to know. We've been doing this, but now we're going to do it a little bit backwards, okay? So this is, if I give you the root, can you tell me what the factor is? We go from factors to roots all the time, and we have been for quite a few months, all right? But now we're going to be going from roots to factors. So if I tell you that the root is 4, what is the factor? Very good. X minus 4. Okay? It always is backwards. It's changing that sign just like it does when you pull it out and it changes signs. What if I tell you that 3 is the root? What's the factor? What if I tell you that negative 5 is the root? What's the factor? Okay, be really careful with this one. All right? What if I tell you that negative 1/2 is the root? 2x plus 1. Okay? Remember, look, if you solve this right here for x when it was set equal to 0, you would subtract 1, there's that negative 1, and then you would divide by the 2. Remember that the denominator is that coefficient, okay? And the numerator is the number. All right, everybody okay so far? Okay, so there's one other thing that you have to know. They're going to use some verbiage or some language, and it's going to say of least degree. So I need to explain to you what that's talking about, okay? So here's what, let's just look at this. What if I give you a graph?
Do you want to draw a graph?
Yeah. Now, let's look at this. Now, first of all, just looking at it, you know that he is what type of a function?
Odd.
Odd. How did you know that?
It's odd and negative.
That's right. He is odd. He begins and ends in different directions, and his leading coefficient must be negative because he goes down at the end, okay? His right-hand behavior. That's exactly right. Okay, so let's talk about this. This right here, what's this root right here? Negative 2? What's the factor? X plus 2. Okay? Now, his multiplicity has to be what kind of a number? Even or odd?
Even. Odd.
Why?
Because it goes through.
Because it goes through it. When it goes through it, it has an odd multiplicity. Okay? So, it could be a 1, but could it also be a 3?
Any odd number.
Any odd number. Okay? So what they're going to do is they're going to say, we're going to pick the least one. So we're going to say it's in first degree. Okay? This one right here is a 1. What's his factor? X minus 1. And his multiplicity is even because it bounces off of it. So it could be a 2, but it also could be a 4 or a 6. Do you see what I'm saying? It could be any of those. But because of the verbiage and the words they're using, then we're going to say it's a 2. Okay? Because it says of least degree. All right, everybody understand it? Okay.
It's like of least possible degree to
That's-
still obtain this graph.
That's right. That's right. So, and really they're making it as easy as they can make it on us. Okay, so here we go. I want you, no. Why did it do that? Yeah, it did. Well, it didn't turn off. It just disconnected. Just all of a sudden. Yeah, you can. First you need to punch the mouse button. Don't punch it. Just touch it. Yeah, for some reason it's been like
Off the
kudos.
Never them all. What?
Ooh.
Oh, how profound. It's jumping over to the side.
Okay. I know. It's not. It's obviously it's not oriented.
What are you trying to write?
Hi.
Stop saying it.
Okay. Oh, sir.
Infernal machine, I give up.
Okay. So remember, I loaded your video. So it's okay.
What's that infernal machine?
The word that I'm not going to say.
Alright. So, we loaded your video, so it is on there. Remember, I lost it, but you found it in the trash can. I couldn't find the trash can.
Yeah, she deleted all her videos before uploading.
So, but Spencer found it for me in the trash can. I couldn't. I thought it was down here in the corner. So obviously it wasn't. Y'all call it something else. A recycle bin.
That was a failure.
Okay. So, oh, we're fixing to work a problem. Here it is. Write a polynomial function of least degree with a coefficient of 1 and having, see, it's like a long drawn out instructions, and having zeros of 2 and negative 6. Okay, so 2 and negative 6, what kind of polynomial does it have to be? A quadratic, an x squared. It has 2 roots, it has to be an x squared, okay? So if 2 is the 0, what's the factor? Okay, if negative 6 is the 0, what's the factor? Okay, so there's my function. Yes? Now, we're going to multiply them out, okay? So, when I multiply them out, first times first, what do you get? Perfect. The inners give you a negative 2x, and the outers give you a positive 6x. So, what's that make?
4x.
Perfect. And last times last is? Awesome. Now, how would I check this? And do what? Yeah, and I'm looking for, to make sure my zeros, it crosses the x-axis at 2 and negative 6. Okay? Does everybody understand? Okay, so let's try another one. Oh, now instead of giving you the numbers, I gave you a picture. We're still going to follow the same directions, okay? We're going to write a polynomial function of least degrees, and I'm going to say his leading coefficient is 1. If I said his leading coefficient was 2, what would I have had to do to this problem right here? Yeah, just multiply everything by 2. It's not a big deal, okay? Not a big deal. I wouldn't do it till the end, because all you're doing is making your numbers bigger, so that'll be the last thing I did. Alright? So, let's go back to this one, and let's talk about it. So, first of all, tell me about this root right here. What is it?
Negative 1.
So, if the root's negative 1, what's the factor? Okay? Let's talk about this one right here. What's the factor? X minus 1. X squared minus 1. Okay? Yeah. You're thinking right. Okay, this one right here is 3.
So x minus 3 squared.
Oh, okay, because he's a double root, right? Because he bounces off of it. All right, so x minus 3 quantity squared. All right, everybody okay? Okay, so now I'm just going to write them all out. I'm going to say f of x is equal to x plus 1 times x minus 1 times x minus 3 quantity squared. Now, what are you going to do first?
Well, I'll multiply the first two because those are conjugates.
Okay, these are conjugates. I like that. When you multiply conjugates, the inners and outers disappear, and you're just left with what? Square the first minus square the last. It's the difference of two perfect squares. Okay? This one, can I square this one fast? Yes. Has your teacher been trying to teach you how to do this for a long time? Yes. Okay, so square it and tell me what you get.
6 squared plus minus 6x plus 9.
Very good. What's the mistake? What are some kids going to put?
X squared plus 9.
That's exactly right. People, never, ever, ever. I mean, think about all the ways. I tried to teach it to you, first of all, And then we did Pascal's triangle, and it says if you raise it to a second power, you have to have 3 terms in it. Okay? So, x square the first, keep the sign, twice their product, plus square the last. Now, I'm not going to finish this problem, but I just want to show you what you would do. Okay? You tell me what we would do. Yeah, you just multiply x squared times this whole thing. Yeah, and then negative 1 times that whole thing. And then you would collect all your like terms, right? And you would end up with what degree polynomial? A 4th degree, a quartic, okay? And I'm going, oh yeah, it's even, because they're beginning and ending in the same direction. It's positive, so I'm looking good. Does everybody understand? Okay, so I'm not going to finish it, but I think you have the skills to finish it. We're going to do one more problem. These are the most difficult ones, all right? Because so far, this stuff's not been so bad, is it? All right, so what in the world is so hard about this?
Fraction.
Well, no, it's not fractions. No, it's complex or irrational ones. When I put one of those in there, that makes it difficult, okay? Now, I'm going to show you an easy way to do it, okay? But I don't know. Kids just have a hard time with it. So this is example 3 in your book. They tell you that your roots are 3 and 2 plus the square root of 5. And they want me to write the polynomial function. Find my equation. Find the equation. Okay. So, what's the first thing that you notice?
Well, you have to have the conjugate.
Yeah, I said 2 plus 5, the square root of 5, but you automatically know what? 2 minus the square root of 5. Okay? So now, he's not a quadratic, but he is a cubic. He's got 3 roots. Okay? He has 3 roots. I only told you 2 of them. Alright? Now, if this one had been 3 and 2, could you have found a cubic that went with those? No. Okay? You see what I'm saying? It has to be either one like this or it has to have an I in it. Alright, so let's do this. This is the 0, or the root. What's the factor? Okay. Now, let's talk about this one for a second. I'm going to go up here and write something down because the way I write it is going to bother some kids. Okay? Because this is what some kids are going to say. Well, it's really it's really x minus 2 plus the square root of 5, right? Which turns into x minus 2 minus the square root of 5. Do y'all agree with that? Everybody okay with that? Well, look what this one does. This one becomes x minus 2 minus the square root of 5. So he becomes x minus 2 plus the square root of 5. So we just write them, okay? We're just going to write them. I know they're both going to be there. I don't really even care, okay? All I know is that they're both there, so I'm not going to worry about anything else. X minus 2 plus the square root of 5 and x minus 2 minus the square root of 5. Order does not matter. If it bothers you that this is not really this, then put this one as a minus and this one as a plus. I don't really care, because multiplication is what? Commutative. Very good. All right. It starts with a C and has how many T's in it? 2. Because we don't say it like it's spelled. We don't pronounce it properly. It's commutative. Okay? So please, we say commutative because if I had to say commutative, I would get tongue-tied and my tongue would get all tangled up. All right? So, but just know that that is the way it is spelled. Okay, so look at this mess. We got to multiply this stuff. I'm going to multiply this one last. I'm going to do these 2 first. Now, let me tell you what really the object of the game is. The object of the game when you multiply these things is everybody gets multiplied by everybody, right? But what if I could show you a short way to do it that you could have almost the answer in one step? That would be pretty cool, wouldn't it? Okay, so watch what I'm going to do. I'm going to reassociate things. Instead of putting that 2 with the square root of 5, I'm going to put the 2 with the x. Okay? Now watch what I've done and why I do that. Okay? When I do that, I have created conjugates, haven't I? This plus the square root of 5 and this minus the square root of 5. Okay? Now, when I create conjugates, remember how fast they can be multiplied together. All you do is square the first. Now, some of y'all can square that right there, can't you? I'm okay with that. I don't have a problem with it at all. And then minus square the last. If you had squared this right here, you just collect your little like terms, and your next step would be your answer. Okay? I wrote it so that people would know what I was doing. Okay? They would know where I got that. Because I multiplied, you can call it, I multiplied the white plus the square root of 5 and the white minus the square root of 5. So conjugates. How do you multiply conjugates? We just did it right over here. You did it. Square the first minus square the last. It's the same thing over here, guys. Square the first. The first is the white, all right, so I squared it, minus square the square root of 5, and I just got 5. Okay, so let's go do that. What is x minus 2 quantity squared? Minus 4x plus 4, and then you have your little minus 5. You collect your like terms there, and you got x squared minus 4x, what? Minus 1. Good job. And now it looks just like that other one did, but we're going to finish this one, okay? So we're going to multiply. Remember, always separate the small one. You could separate the big one, people. It doesn't make any difference. All I'm doing is being methodical about how I multiply everybody by everybody, okay? Instead of just haphazard, shooting and hoping I hit something. All right, so x times the long one, x squared minus 4x minus 1. And then this one, his sign goes with him, minus 3 times x squared minus 4x minus 1. Okay, I'm also going to do this other little trick, okay? When I multiply them, I'm going to line them up vertically, because a lot of y'all like that, okay? So I'm just going to make sure you remember we could do that. X times x squared is x to the third. X times negative 4x, negative 4x squared. X times negative 1. Okay, now here my brain goes, ooh, you better be careful. You're distributing a negative. What is it going to do to all these signs? Change them. Always be aware of that, guys, because that stunts and messes up a lot of kids. What's negative 3 times x squared? I'm just lining mine up because people like to add like this. It's easier. What's negative? You don't have to do it this way. What's negative 3 times negative 4x? What's negative 3 times negative 1? Positive 3. Okay, so now I'm going to go down. There's my x to the third. Negative 4x squared, negative 3x squared, negative 7x squared. Negative x and 12x is 11x plus 3. How could I check it? Plug it in. Graph it. Now listen to me. When you graph this thing and you run into these, they're going to look like decimals, aren't they? But you can just plug that. 2 minus the square root of 5, 2 plus the square root of 5. You can plug it in your calculator. It'll tell you what decimal it is, and that way you could just jot it down beside it, and you could check it really fast. Okay? All right, so I want you to work 2 problems. That's it. On page 384, all I want you to work is 23 and 27. Okay? 23 and 27. That's for homework. I just want you to work it, okay? I'm not taking it up or anything like that. I'm just saying it's going to be beneficial. And why? Because have I given you a lot of homework to do? No. So, have you been practicing outside of class? Okay. I know you haven't been practicing outside of class because the only time you practice outside of class is when you have to practice because the teacher's taking it up as a grade. Okay? So, I'm just saying, be a good thing to do that. All right.